Alright, welcome to a video talking about congruent triangles. And when I say congruent triangles, I mean side, 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 angle, side, angle, and angle, angle, side. Now this video is just going to be theorems, definitions of these. I'm not going to do any examples. I want you to be able to take these theorems, definitions, and put them to use in the examples. So, side, side, side. And this is a postulate. A postulate is a little bit different than a theorem. Postulates are things that are true and they're obviously true. Theorems are a little bit different. Theorems can be disproven, possibly, or most of the time they work. So, side, side, side postulate. If three sides of one triangle are congruent to three corresponding sides of a second triangle, then the triangles are congruent. So we see AB congruent to XY, BC congruent to YZ, AC congruent to XZ, and then we have two congruent triangles. So if that happens, we can say that triangle ABC is congruent to triangle XYZ. So if all the sides are congruent, then the triangles are congruent. Okay, now we're going to talk about the side angle side theorem. If two sides in the included angle, included means the angle in between, are an included angle, I've added a little bit too much there. Included angle of one triangle are congruent to the corresponding two sides and included angle of a second triangle, then the triangles are congruent. So, if we have AB congruent to XY and BC congruent to YZ, and angle B is congruent to angle Y, and angle B and Y are the included angle, and you see that they're the angle that's in between the two sides, then we have two congruent triangles. So we can say triangle ABC is congruent to triangle XYZ. Our third theorem is angle side angle theorem. If two angles and the included side, so now we have the side that's stuck between the two angles of one triangle are congruent to the corresponding two angles and included side of a second, and then the triangles are congruent. So if AB is congruent to XY, the segment, and angle A is congruent to angle X, and angle B is congruent to angle Y, and AB and XY are the included angle, then we have two congruent triangles, which is what we have right here. Our last theorem is the angle side theorem. This says if two angles and the non-included side of one triangle are congruent to the corresponding two angles and non-included side of a second, then the triangles are congruent. So now we're talking about sides that are not included, which means that they're not going to be in between our two angles here. So we see that BC is congruent to YZ, angle A is congruent to angle X, and angle B is congruent to angle Y. But we also have to notice that right here, A and X are the two congruent sides, which means that if BC is across from A, then YZ has to be across from X, which it is. If there was a different side, then they would not be congruent. But it is, so we have angle A, or triangle ABC, is congruent to triangle XYZ. So those are your four theorems, postulates that we're going to use. So go ahead, when you feel like you're comfortable with this, you can get started on the practice problems.